optimize an algorithm locally using the LEAN CLI, open the project in your preferred editor. In this editor, open the project's config.json file and update the parameters object with the parameters that you want to optimize. In this object, the keys of the properties are the names of the parameters and the values are the default values. For this example, I will be using a simple crossover algorithm which has a fast period which defaults to 5 and a slow period which defaults to 25. After configuring your parameters, go back to your algorithm. In your algorithm, you need to retrieve the values of these parameters at runtime instead of relying on hard-coded constants. You can do so using the Getparameter method on QC algorithm, using self.getParameter in Python or this.getParameter in C#. This method requires one argument, which is the name of the parameter that you configured in your config.json file. In my case, that's fast period and slow period. Because getParameter returns a string, you also need to convert the return value to the data type that your algorithm needs. After configuring your parameters, open a terminal, run the lean optimize command, and provide the path to the project as argument. This command starts an interactive wizard which lets you configure the optimizer. First of all, you need to select the optimization strategy that needs to be used. You can choose between grid search, which goes through all possible parameter combinations, and Euler search, which starts with large step sizes and gradually makes them smaller as it approaches its target. For this example, I will be using grid search. Then you need to select the optimization target. This is the statistic that you want to minimize or maximize. Simply enter the number in front of the target and hit enter. After that, you need to configure the parameters that need to be optimized. For every parameter that you want to optimize, you have to enter the minimum value, the maximum value, and the step size. In this example, I will be setting the fast period between 1 and 5, step size of 1, and the slow period between 20 and 30 with a step size of 5. After that, you can configure the constraints. Constraints allow you to drop parameter combinations from the final results when they give unwanted statistics, like unnecessarily high drawdowns. In this example, I will leave them disabled. After configuring the constraints, the optimizer starts running automatically. The optimizer will run multiple instances of your algorithm in parallel, with parameters set according to the chosen optimization method. This may take a few minutes to a few hours, depending on how you configured the optimizer in the previous steps. When the optimizer has finished, you can find the optimal parameter combination at the bottom of the logs, and the detailed backtest results of all the backtests that were ran in the optimization's output directory.